Today we are going to talk about finding inverses of relations and functions. Alright, the very first thing that you can do with any of these is you can always graph these out. If you've noticed, we have an ordered pair here, and here, and here. So we could graph these, and we've got 3, 8, 2, 1, 2, 3, 4, and 7, 11's approximately there, so. Now, one thing we could do to find the inverse of this is we can draw in the line y equals x here. Alright, and that's just this diagonal line here that cuts right through the middle of the graph. Obviously it goes down here too. Alright, I'm going to leave that alone because all of our points are in the first quadrant. Alright, the very first thing that we could do is dealing with this point right here, this point 2, 4. Alright, if you notice, if you were to draw a perpendicular line through here, it is exactly one box away here. Alright, which means all of these points are going to be down here, and it's going to be the exact same amount flipped across there. So we are exactly one box away here, which means we have to be exactly one box away down here also. Notice that this point here is the point 2, 4. This new point is the point 4, 2. Alright, we'll talk about that in a second. This next point up here is, if you draw this perpendicular line through here again, it is 2.5 boxes away between the point and the line, which means we would have to be 2.5 boxes away too, which would put us right here. This point here was the point 3, 8. This new point is the point 8, 3. Now you could do that for every single one of them, okay, but we don't want to have to graph every single one of these. If you noticed here, this was our original 2, 4. It became a 4, 2. What did we do? We switched the x and the y. Same thing up here. We had a 3, 8. Flip the x and a y, it becomes an 8, 3. And then this last one, which is the point 7, 11, would be over here somewhere as the point 11, 7. So it says find the inverse of this relation. Well, the inverse would be the point 8, 3, 4, 2, and 11, 7. All you do is you switch the x and the y. Alright, so you don't even need to graph this unless you absolutely want to. If we go to our next one, find the equation for the inverse of y equals 8x plus 14. Well, what we could do is we could graph this out again. We could graph this, and I'm going to make each box worth 2 so that you can see this, which means we've got to go up 7, 6, 7, so we would be here. Alright, and then our slope is 8, so that means since each box is worth 2, we'd have to go up 4 boxes, which would get us off the graph and then over 1, or over a half. Or what we could do is we could go down and then back. Now with the slope of 8, this doesn't really matter here. We can just go down 8, so 1, 2, 3, 4, 5, 6, 7, 8, and over 1. And then we draw in this line, hopefully as straight as possible here. Now what we're going to do with that line is, as we said with the last problem, we can flip this over this line y equals x, alright, for this entire thing. Now if you notice, this bottom part here is going to flip over here somewhere. This top part is going to flip over here. This 1 point though, that's on the line y equals x, is gonna stay on the line y equals x. So this point at -1, is gonna stay -1, -1. Now this point up here, which is the point 0, 7, we could flip that x and y and make that a 7, 0. All we need is 2 points to make this line. So we draw that line in the best we can. And that is the graph of the line. But this says to find the equation, and that's going to be really rough to do. So once again for this one, I wouldn't even make this graph out of it. I showed it to you so you can see what's going on. But what I would do with this equation is I would switch the x and the y. So we've got x equals 8y plus 14. And then the last step we have to do is solve for y. So we've got to subtract 14 over. And then we divide by 8. So we would get y equals 1/8 x minus 14/8 is the same as 7/4. All right. And remember that this box, each one of these is worth 2 here. So it's fairly close. You can see that my line is kind of curved in there. All right, so it's not perfect, but you can see that this is approximately 7/4, 1 3/4. Okay, and then our slope of 1/8 is going to be really flat, which is kind of what this graph is showing here. All right, so that is our equation of the line. All right, our next one, find an equation for the inverse of y equals 2/7 x cubed plus 8. Use the vertical and horizontal line test to determine whether each relation is a function. Well, what we can do first is we could graph out this original problem. All right, so we haven't graphed these before, so I would make an XY chart here. All right, and put in points until we know what this graph is going to look like. So I'm going to start with the 0. If you throw 0 in here for x, 0 cubed is 0 times 2/7 is 0 plus 8 is 8. Throw 1 in there. 1 cubed is 1 times 2/7 is 2/7 plus 8 is 8 and 2/7. Throw a 2 in there. 2 cubed is 8. 8 times 2/7 is 16/7 plus 8. And this is the same as 2 and 2/7 plus 8. So this ends up being 10 and 2/7. And as you guys know, this is going to fall off the graph there. So we're going to go the other way now and say these were both above. Now we need a -1 in there. -1 cubed would be -1 times 2/7 would be -2/7 plus 8 would be 7 and 5/7. Throw in a -2. -2 cubed would be -8 times 2/7 would be -16/7. So I'm going to make this a negative here, which would make this a negative. So -2 and 2/7 plus 8 would be 5 and 5/7. Alright, and that should be enough to be able to get at least a decent idea what this graph is going to look like. 0, 8 is up here. 1 and 8 and 2/7 would be approximately there. 2 and then 10 and 2/7 we'll say is about there. -1 and 7 and 5/7 there. -2 and 5 and 5/7. A little bit less than 6, so approximately there. Now what we have going on here is we have a line that kind of looks like this. Alright, a cubic, which is what we have up here, every single time we have one of those, it's either going to start low, like this one does, and end high, or it's going to be the reversal of that. Start high and end low. Alright, so it's going to be one of those two. That's what we have for this one. So this works out really well. Alright, use the vertical line and horizontal line test to determine whether each relation is a function. Well, if we look at this graph and we use our pencil to draw in vertical lines here, we're never going to hit that graph more than once. So the original is a function. Alright, we'll have to tell if the inverse is a function also. Now, how we can do that is, first of all, we've got to find an equation for the inverse of this. Well, we do know what points are here. Alright, we have switched the x and the y for all the rest of them. We can also do that for our points also. So we started with this 0, 8. It can become 8, 0, and then 8 and 2/7 and 1, 10 and 2/7 and 2, and so on. So I'm going to graph these out quick. So we're at the point 8, 0, 8 and 2/7, 1, 10 and 2/7 and 2, so approximately there. And then we're at 7 and 5/7, negative 1, and 5, 5 and 5/7, and negative 2. Now what we see here is we see this graph. Alright, now go back and pretend that we have this line y equals x here. Alright, and you can see that our original, if you flip that over this, then it is going to end up something like my red line here. Alright, so that's what the graph looks like. We can tell from the inverse that if we use a vertical line test, that the new function is also a function. Now, if you wanted to, if you just graphed out the original and you wanted to tell if the inverse was a function or not, you could use what's called the horizontal line test. And it's the same thing as the vertical line test, except it's horizontal. If you only cross that line once in every spot, then it is also a function. You can tell that from actually graphing out our inverse and seeing it that way also. Alright, now that's all great, but we still haven't answered the first question. The first question was find the equation of the inverse. Well, we've got this equation here. We can, just like we did before, we can switch the x and the y. So x equals 2/7 y cubed plus 8. And then we have to solve for y here. So we can subtract 8 over. And we've got 2/7 y cubed. Alright, we've got to get y by itself, so we would normally divide by 2/7. We can't divide fractions, so we can multiply both sides by 7 over 2. Just multiply by the reciprocal. So 7/2 x minus 8 times 7 is 56, divided by 2 is 28, equals y cubed. And then to get y by itself, we take the cubed root of each side. And if you were to grab either a graphing calculator or throw it on Desmos, and you type in this equation, you would get approximately that red line. Alright, and this would be the equation that answers our problem here. Alright, next problem. Alright, find the inverse of y equals 3x squared minus 9. Alright, so what we can do with that right away is find the inverse. So switch the x and the y. So we've got x equals 3y squared minus 9, and then solve for y, so we're going to add the 9 over, divide by 3, so we end up with 1/3 x plus 3 equals y squared. Take the square root of both sides, so we end up with y equals the square root of 1/3 x plus 3. Alright, now if you were to graph this out, okay, we know that this equation, if we were to graph it, would be some sort of parabola going up. Alright, if that were to flip over a line, y equals x, what would that parabola look like? It would look something like that. Alright, now, what happens with this one though is, as we can see with a vertical line test, the original is a function. If we go through this, our function, or our inverse, is not a function because it fails the vertical line test all over this graph. So what we have to do is we need to restrict the domain so that the inverse is a function. Alright, so what we're going to do first with this is we're going to actually graph this out. So, if we did negative b over 2a, we find out that our vertex is at the point 0, negative 9. Alright, and then if we throw some points in, throw in a 1, we get a negative 6. Alright, it's going to be the same over here. Throw in a 2, we get 12 minus 9 is 3. So, we would be up here for both of these. So, our original graph would look like that. If we were to flip all of those points, we would be over here. And alright, so that would be our graph of both the original and the inverse. Alright, it says, now as you can see with the red line, it is still not a function. So we need to restrict the domain of the original function. Now, if you notice, this bottom half of the red line is the same or works together with this half of the black line. Alright, if I were to simply erase this part of the black line, what would happen to the red line is this half would be gone also. And now our red line is a function. So what we could say for this, then restrict the domain so that the inverse is a function. If we said that the domain is x greater than or equal to 0, that would give us this half of the graph, which then when we do the inverse would give us this half. Okay, and that's one way of doing it. The other way would be saying x is less than or equal to 0, which would have simply given us the other half of the graph. Let me get back to that. Alright, so we've got this graph. If I were to say that the domain is x is less than or equal to 0, that would have gotten rid of this part of the black line, and that would have gotten rid of this part of the red line. And that red line is now a function. So your answer for this can either be, for this one, can either be x is less than or equal to 0, or x is greater than or equal to 0. Alright, we will work with this more in the upcoming lessons on how to restrict this domain to get this function. The easiest way to do it, believe it or not, is to graph this out and to actually look at the graph, and then you have to get rid of half of it. And how you get rid of half of it is up to you to either get one of these two types of answers. Alright, last one. The distance traveled by a boat over a period of time was recorded as d equals 8t cubed plus 7, where d is distance in miles and t is time in hours. How long did the boat travel if d equals 519? Now this feels like it has absolutely nothing to do with what we just talked about. And what most of you would do is say, alright, I know that d equals 519, I'm going to plug that in for d. And there's nothing wrong with that at all. So d equals 8t cubed plus 7. You would subtract the 7 over, so you get 512 equals 8t cubed. Divide both sides by 8, so t cubed equals 60, let's see, what is that? 64, and then you would take the cubed root of both sides, and t would equal 4 hours. And that is by far the easiest way to do that. Technically, if you wanted to, you could switch the d and the t here, solve for d, do all that work that we did with all the inverses, and you would still end up with the same answer. It is a lot of wasted work though. I would just plug it in and solve for what they're asking for, and then move on. I will be back tomorrow to answer any questions over this. Go ahead and get to work.